Okay, I'm back, and in our previous segment, we talked about the formation of the solar system. And so now the question is, what happened to the rest of the material? So I would say about 99% of the original gas cloud and the original dust in it turned into the solar system. But there was still a whole bunch of rubble left over from the formation of the solar system. So where is it today? So that remaining debris is in the form of the asteroid belt. So that is a belt of material in between the orbits of Mars and Jupiter. And it only consists of rock and metal. So there's not much ice out there because it's still inside the ice line. Okay, then outside of the orbit of Neptune, you're going to have the Kuiper belt. So I know it looks like Cooper, but it's pronounced Kuiper. So in the Kuiper belt, you're going to also have rocks and metals, asteroids out there, and you're going to have a lot of ice because that's in the outer part of the solar system. Notice that Pluto is in the Kuiper belt. Okay, then finally, you're going to have another area of debris that is spherical. So the asteroid belt and the Kuiper belt are belts that are in the plane of the solar system, but the Oort cloud is a sphere. So it's a sphere that surrounds our entire solar system and goes about halfway to Alpha Centauri. And so it has also a lot of rubble in it. Ice, rock, and metal are located in there. I didn't really have a good picture of an asteroid belt, but I did have a picture of the Millennium Falcon flying through an asteroid belt. So in case you were wondering what that was a picture of. Okay. Couldn't help it. So why do solar systems differ? So when we've looked at other solar systems in our galaxy, we've found that they don't exactly have to be the same as our solar system. So one reason is the initial composition of the solar nebula, the cloud that forms the solar system. Imagine that you had a cloud that was consisted of 100% hydrogen and helium. Okay, then what would our solar system be like today? Would we be here? No, because we, the planet and us, are all made of that 1% dust that was in that cloud. So the elements in the cloud will also determine what kind of planets that you're going to end up with. Okay, the mass of the nebula. So we're going to find out that if the nebula is too small, it just doesn't have enough gravity to pull it in and to turn it into a solar system and a star. On the other hand, if it has a lot of mass, well, then that means you're going to have a very big star, and then that's going to affect the gravity, which is going to affect the orbits of the various planets that are going to form. Another thing is the angular momentum. So the angular momentum is the spin. It's the combination of the mass of an object, the speed of an object, and its radius. So imagine that this thing was rotating not very fast. So the initial spin of the gas cloud was very, very slow. Well, then that would mean that when it starts to contract, it will speed up, but not as much. Okay, and then remember that centripetal force thing? So the centripetal force was F was equal to mv squared over r, where r is the radius, v is the speed at which the disk is going around and around. So if it's not rotating very quickly, then that would mean that the centripetal force is not going to be as strong, which means that the disk is going to be smaller than what it currently is. So the speed at which the disk is going around is going to influence the size of the disk. And then that's going to influence what kind of planets that you're going to end up with. And then the number of stars in the system, remember we talked about a binary star system that would have 2. And then we also talked about there's also trinary star systems that can have 3. Well, how would that affect the solar system? Well, one, twice the number of stars means twice the amount of energy being given off. So that would affect the temperature on the various planets in the solar system. And then imagine the gravity. So a planet would feel the gravity of 2 stars instead of the gravity of 1. So instead of having an orbit that might be a nice ellipse, because you remember that planets go around the sun in ellipses, well, maybe if there were 2 stars, then the orbit might be kind of weird, because it would be feeling the combined effects of the gravity of 2 stars. Would that be good or would that be bad on an Earth-like planet? It would be bad, okay, because if it got too far away, it would get too cold. If it got too close, it would get too warm, and life would not like those kinds of changes. So you can see that there's a lot of things that go into making a solar system, and it's a pretty good thing that we have such a nice one to work with. Okay, let's take a break, and when we come back, we'll do a little bit of math.